Hello students, welcome to physics class for senior secondary 2. In today's lesson, we will be learning about position, distance and displacement. Before we proceed, let's take a look at our lesson objectives. At the end of this lesson, we will know what position, distance and displacement are, the difference between distance and displacement. Also use calculations to solve some problems relating to distance and displacement. Are you ready? Let's go. First up, position. Think of position as where something is located. It's like giving an address for an object in space. For example, if I say a tree is 10 meters north of your house, I've described its position using a reference point, your house. It's that easy. Let's keep going. Now, distance. Distance is the total length of ground you've covered when you move. It doesn't matter which way you go or how many turns you take, it's all about the length of the journey. For instance, if you walk 6 meters forward and then 4 meters backwards, the total distance you traveled is 10 meters. It's not too difficult. Next, let's talk about displacement. Here's where it gets interesting, displacement. Displacement is like saying, what's the shortest straight line path from where you started to where you ended? And don't forget, it also includes direction. For example, a bird flying directly from tree A to tree B, with a straight arrow showing the displacement. Because that's the straight line distance. Do you get it? Now, let's compare the differences between distance and displacement. Distance is a scalar because it only tells us how much ground was covered, without considering direction. For example, walking 5 meters forward or backward is still a distance of 5 meters, it's just the total length traveled. Displacement is a vector because it describes the straight line distance between the starting and ending points, and it also includes direction. For example, walking 4 meters north is a displacement of 4 meters in the northward direction. Now, let's solve some problems on distance and displacement. Let's see this in action. Imagine a boy rides a bike 4 meters from point A to point B, and then 3 meters from point B to point C and finally 5 meters back to point A. Can you find the total distance traveled and the displacement? Solution. To find the distance, we just add everything up, 4 plus 3 plus 5, which gives us 12 meters. For displacement, since the boy starts at point A, travels to points B and C, and then returns to point A, the initial position and final position is 0. There is no displacement. See how it works. Let's use a second scenario. Imagine someone walks 2 kilometers east, 4 kilometers north, and then 2 kilometers west. Solution. To find the distance, we just add everything up. 2 plus 4 plus 2, which gives us 8 kilometers. But for displacement, we only care about the shortest path from start to finish, which is 4 kilometers north. It's not too difficult. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Great job so far. Let's recap. Position tells us where something is, relative to a reference point. Distance measures how far you've traveled in total, it's a scalar. Displacement is the shortest straight line path from start to finish, it's a vector. Remember, distance and displacement are like 2 sides of the same coin, but they are not the same. In our next lesson we will be learning about speed, velocity and acceleration. Well done. You've come to the end of this lesson. Keep practicing what you've learned. I will see you in the next lesson.